Okay, this is another quick overview of our structural modeling project web application software. I'm going to pick up a little bit on where we left off the last time. We're looking at the basic three functions of the software, the structuring software, that came out of the appendix in the Interactive Management Handbook by Warfield. So what we're looking at today, what we've improved today, we'll talk about the cluster objects into classes. So I've updated the software. So first of all, we'll just take a quick look at the detailed information that's in the it's provided with this particular version of the software. And again, the introduction talks about where the application of the simple system structuring problem came from, trying to connect it back to classical literature, and we'll connect it to other sources as we go forward. But it's we're working with the natural language relationship is in the same category as this particular case. This natural language relationship has the reflexive, symmetric, and transitive logical properties. And each cluster will contain one or more of the same objects. And basically, they'll have a green background in the matrix and vector cells if they're the same. The green background matrix cells will contain the 1, and the green background vector cells will contain the object number. We'll work on making that more explicit and as we go forward with the interface. So this computer code here is different from the computer code or computer interaction that was presented in the handbook, because in the handbook, the computer just asks you questions. In this case, it doesn't ask you questions, it presents the matrix. Then you need to have kind of a manual search process or a manual algorithm that drives your search through the system. And we will, as we develop the software, we'll have the manual part to help develop algorithms. And then we'll have an automated part which will implement algorithms. So both cases, the software will be able to use it to either develop algorithms or to implement and distribute them. So then let's go through and it just shows screenshots, what it looks like, what are each specific step as you go through. You can see here, I'm just going to run through this quickly because I will show it on the main application, but it goes all the way through to the end. So I think one of the things that is important here, so we get to the end, there is no yellow. There are no unknowns, okay? So we've gone from unknown to known. We've got equivalence and not equivalence. Known, true, and false. So at the end, there's no yellows. And at the beginning, when we started, we had a lot of yellows, and then, of course, on the diagonal, we had green ones because we know that something is the same as itself, so things are always equal. Okay, let's go back and look at the look at this particular interface now. We'll display this. So a cluster of equivalent objects, again, unlike many of the other applications that we've been working with, this one is symmetric, so it has green ones on the diagonal. And the enter column number and the enter row number, this is where you, once you're doing your manual search, then you kind of look at that and you enter the numbers here and then enter the data. And the detailed description document that we just looked at will have some information on the manual search. We said later on we'll put an automated search in. But right now let's just kind of go ahead and run through this real quickly. So here we can see that we go through and it's what is done now, it's identified we have 4 classes, and that it just says is class 1, right, is equal to itself. Class 2 is equal to itself. That's if these green ones are on the diagonal. But class 2 is different, is known to be different then class 1, and class 2 is known to be different than class 3, and class 2 is also known to be different than class 9. So we know, as a matter of fact, that these are all different from each other. But down here we have the class. So here's class 2, which contains the object 2, 4, and 8. It's class 3, which contains the objects 3, 5, and 11. There's class 1, which contains the objects 1, 6, 7, and 13. And class 9, which contains the objects 9, 10, and 12. These asterisks here are just placeholders for when you have a ragged matrix, so that these really are just placeholders in this case. So that's essentially what's going on with this software. You can see it goes from unknown, you work through the steps, to known. We've changed it so that we have the green known to be true. We now know that these are all, right here in this area, we know that these are true from empirical data. We can see it here from the legend. From empirical data, these are known to be true. From empirical data, we know that something is equal to itself. It's also known to be true. From empirical data, we know that these are false, right here, right? Because that's what we've asked. We've asked that question and they're not the same. We haven't inferred anything. We've asked the question, we've asked the information. Next, I expended the resources to get this information. We're not really inferring anything in this case. But as we did when we started out, right, we know that we had a lot of unknowns. A lot of unknowns, and then what we're doing here is kind of like is a way that we go from unknown, you gather information, and then it goes to known as you're exploring an area. What we're doing is we're trying to optimize, well, trying to minimize the amount of resources it takes to actually get the empirical data. So that's basically the overview of this new set. We'll be working on a little bit more. And this only thing that's been improved so far is the cluster. I'll start working on the other two as the next set of iterations of the software. Detailed instructions are here at this link. You just click that link, and you get the instructions on how to do the manual search. So with that, I'm going to stop this broadcast, and I'll have other short broadcasts as the web application is add function and update it.